Today we are going to learn about robotics and how you can build a simple robot using the kits provided by Pinwheel Robotics and Intern 360. So let's jump to the session now. So first we will going to discuss about the fundamental function of a robot. So for any robot, what should the fundamental function? It should be like the robot should be able to take commands from us, or it should be able to judge the environment and perform some specified tasks. So let's say it's like we are designing a robot that should follow a line and it should move on the line. So here the robot has to judge the situation that whether the line is there or not, and it should be able to move on the line. So let's say if the robot is going in a certain path, when it sees the line is going in a certain different path, the robot needs to change the direction and move to that path. So that is the most fundamental function of a robot. Now, in order to achieve that kind of a thing, what do you need? So, as you know, means like a robot should be able to move. So, in order for anything to move, you need a motor or engine. So, the most important part of the robot will be a motor. And for let's say if you are building an autonomous robot where it should be able to judge the situation based on its own, it will need some kind of a sensors or camera. Also, if let's say you are building a manual controlled robot, you will need some remote for the robot to work. So, in order to accept the commands from the remote, the robot should be able to just the command. So it should have some kind of a communication module to just the command. Now that communication can come from wire. That communication can be a wireless. So if it's a wireless communication, you need to use a radio frequency module or maybe a IR sensors like in a TV remote. Now we will come to know about like what are the different types of motors and what motor we are going to use. So there are various kinds of motors available in the market. So you can have the DC motor, you can have a stepper motor, servo motor, etc. So different motors are there for different purpose. So let's say if any place you want more precision, you should use a servo motor. If you want a controlled motion, you should use a stepper motor. We are going to use a simple DC motor for our purpose for because of its simplicity. So in a DC motor, uh, in a robot, you know you need to change the direction of the motor. So how do you change the direction of the motor? By changing the polarity of the voltage to the motor terminal, you can change the direction of the motor. So let's say your motor is connected, plus of the motor is connected to the plus of the battery, and the minus of the battery is connected to the minus of the motor. The motor will go in a clockwise direction. If you reverse the polarity of the battery, the motors will start going in the anti-clockwise direction or counterclockwise direction. So this concept is going to be used very widely while you are building any kind of a robot. So in order for any robot to work, we will use two robots at minimum for any robot to function so that we should be able to change the direction of the motor. And when we use two different motors, we will also need to control the direction of the two motors. And when we control the direction of the two motors, we apply the concept of differential drive mechanism. So in a differential drive mechanism, what happens is that as you can see in the diagram, if both the robot motor is going in a forward direction, then your robot will move forward. If one motor, that is the left motor speed is less and the right motor speed is more, it will go in the left direction. Similarly, if the right speed is less and the left speed is more, it will go in the right direction. And if let's say your motor's left motor is going in a forward direction and the right motor is going in a reverse direction, it will start spinning at its own position. So this is how you can achieve a different direction of the motor, different direction of your robot. So you can maneuver the robot based on this concept. So now you know it's like you can change the direction of the motor and in turn you can change the direction of the robot by changing the polarity of the battery. But how often can you change the polarity of the battery manually? You will not be able to change it while your robot is in motion. So in order to achieve that, we need some kind of a special switch which should be able to swap the polarity of the motor, so swap the polarity of the battery going to the motor. So here we are going to use a DPDT switch. So that is called a dual pole, dual throw switch. So you can see in a DPDT switch there are 6 terminals and 2 terminals of the center terminals of the DPDT switch will connect with the power supply, that is the plus and minus of the battery. And the 2 terminals of the switch will connect with a single motor. And these 2 terminals will swap it using a cross connection to the other 2 terminals. So what happens is that when your switch is in position 1, so let's say this is position 1, your plus of the motor is going to the plus of the plus of the battery is going to the plus of the motor and minus of the battery is going to the minus of the motor. Now when you, so this will turn your motor in a clockwise direction. Now when you change that switch position to switch 2, what happens? Your plus of the motor battery is going to, so in this position, your plus of the battery is going to the minus of the motor, and minus of the battery is going to the plus of the motor. So this makes your motor to go in a counterclockwise direction. So just by changing the switch position, you will be able to change the direction of the motor. So so when you use two of such kind of a switch, you can control two different motors, and you can make your robot to go in a forward, left, right, backward, and any kind of a motion for your robot using two different switch. But this is good for when you are building a remote controlled car or when you are going to control your robot manually. But what happens when you are building an autonomous car? So in case of autonomous robot, you need to use some kind of a IC which should be able to do this DPDT operation just by the input signal. So one such kind of IC that we are going to use is called as a motor driver IC L293D. So but how do you change the direction of the motor? You would not be changing the polarity of the battery while your motor is operating. You would want to operate it using some switch. So you should use some kind of a switch where you can just by uh, changing the switch position, you should be able to change the direction of the motor. So for that purpose, we normally use a DPDT switch that is called a dual pole dual throw. So you can see here you have in this kind of a switch you have six terminals. You can see six terminals are there, and what we do basically is that we connect the center terminal to the battery, and we connect the motors to the to other end of the terminal, to these two terminals, and we connect the wire in a cross position. So now what happens is that you can see this diagram here. When the switch is at position 1, your plus of the battery is going to the plus of the motor, and your minus of the battery is going to the minus of the motor. So the motor will go in a clockwise direction. When you change the switch to position 2, your plus of the battery is now going to the minus of the motor, and your minus of the battery is now going to the plus of the motor. So the motor changes its direction to counterclockwise. So this is how you can achieve a clockwise and counterclockwise direction of the motor using a DPDT switch of this kind. So there are various kind of a DPDT switch that comes in the market. This one is the most suitable for the robot because this is very easy to use. The other kind of a DPDT switch you can get is a sliding kind of a switch. Now you can use this DPDT switch if you want to manually control the robot, because here the switch should be controlled by some human being. But let's say if you want your robot to be controlled autonomous, where you don't want human intervention, how can you do that? So in order to achieve that thing, the similar kind of a DPDT switch is being presented by an IC called as a motor driver IC L293D. And the good part is that in order to control two motors, you need a two DPDT switch. But in order to control two motors, you will need a single L293D driver. So this is a most widely used IC in any kind of a robot that you are going to build. L293D motor driver IC, because it can control two motors with a single IC. So, so now here in this IC you can see that you have the two output pins, two pair of output pins. One pair goes to one motor, the other pair goes to another motor. Similarly, you have a two pair of inputs. So input 1, input 2 is for first motor, input 3, input 4 is for second motor. And here the good part is there that by just toggling the voltage at the input 1 and input 2, you can toggle the direction of the motor. So let's say if you have passed 0, 0, the motors will be stopped. If you have passed 0, 1, the motor will go in one direction. If you pass 1, 0, the motor will go in a different direction. Similarly for the motor 2. So here you can control these four pins using any kind of a microcontroller or digital circuit, which should be able to supply a high and low voltage. So here you can see there are two different voltages mentioned here, plus 5 volt and plus 12 volt. So plus 12 volt is the voltage at which the motor should run, and plus 5 volt is the voltage at which your L293 driver IC will be powered, and it will compare this voltage with the input pins in this. So if the voltage is less than 5 volt or maybe 3.3 volt, then this will consider input as a 0, otherwise high and low. So you can read more about L293 DIC on internet and you will come to know about it. But here what you need to know is that you will be using L293 driver IC for controlling any robot in an autonomous fashion. Now in the motor driver IC, you have seen that there are input and output units. So in the input units of robot, what is going to be the input unit of robot? Your sensors is going to be the input unit of robot. Now those sensors can be various. It can be a LDR sensors, it can be a proximity IR sensors, it can be a sound sensor, anything it can be. The other thing that you can do is that you can also control your robot through a remote. So we are not going to discuss remote here, but it is, you can see like how you can control your robot through a remote. Now, when we say sensors, there are two different types of sensors in the market, basically digital sensors and analog sensors. So digital sensors are the sensors which provides you a high and low voltage. So that is plus 5 volt or plus 3.3 volt depending on the voltage levels of sensors. And for low it will be ground. For analog, it can provide any voltage range between 0 to 5 volt or 0 to 3.3 volt depending on the type of sensors. Now, in actual, the basic elements of any sensor is analog, and we use some kind of a circuit to make that analog sensor to digital, because digital sensors is very easy to use compared to analog sensors. So as we saw that digital sensors are fundamentally all the sensors are analog sensors, and we need to convert that to digital sensors. So we are going to take an example of a proximity sensor here. So in the proximity sensor, what happens is that you have two different modules in a proximity sensor. One is called infrared LED, and the other one is the photodiode. So infrared LED, it transmits the infrared signal to an object, and when the infrared LED gets reflected from the object and falls on the photodiode, so when these photons falls on a photodiode, it generates a small signal current on a photodiode. Now this signal current is dependent on the amount of photons uh, that are received by the photodiode. So based on this amount of photons, the current value may change. Now as you can see here, the current value will change, not change in a digital fashion, but in an analog fashion, depending on the number of photons that is reflected on the surface. Now, if there is no object, there will be no reflection and no photons will come on the proximity sensor, and the proximity sensor will not generate any kind of a signal current. So what we do in order to make this analog sensor to digital sensor, we make use of comparator. So you can check your engineering basics and you can learn about comparator. So here in the comparator, what we do is that first we convert the input current on the photodiode to the voltage, and then we compare the V input with the V reference. So V reference is the voltage supplied on one terminal of the op amp, and if the V input is going to be more than the V reference, what we are going to get, if it's an inverting amp comparator, we'll get the output as low, and similarly vice versa, if V in is less than V ref, and we will get the voltage output as high. So we'll get two different output here, high and low. Only two different signals will come. So high will be the VCC and low will be the ground. Now how you can set the reference voltage? So for setting the reference voltage, we are going to make use of a concept called voltage divider or potentiometer. So in a voltage divider, you know the formula to find the voltage divider. So you have two different resistance R1 and R2. So the voltage at this point will be R1 divided by R1 plus R2. So this is going to be the V output, and using this V output, you can set the V reference for the comparator. There are various kind of potentiometer available in the market in a different size factor. So this is one kind, this is another kind, this is another different kind. So you can make use of any of these. Now, the sensors that we are going to use in our kit is already inbuilt with the comparator circuit and the potentiometer. So this potentiometer is the place which we are going to calibrate the sensor. So what you can do is that you can see one signal LED will be there on your sensor, and when you will connect the voltage supply, the VCC and ground to this sensor, you can see if let's say signal LED is off, you can turn this knob using a screwdriver, and you can calibrate your sensor. So you can calibrate the sensor using the potentiometer. So as you know from the previous diagram that you can have a V reference. So actually you are controlling the V reference. So V reference control will actually help you calibrate the entire sensor. Now, the other thing that we will see here is that, like, how can we make any signal to invert? So let's say means like your sensor is giving a high signal, and but for your application you need that signal to be low. So you can invert the signal. So for inverting the signal, we use a transistor in this biasing and in this mode, and you will be able to. So let's say if the signal is 0, your output will be 1, and if its signal is 1, your output will be 0. So why we are discussing this thing? Because in the board that is being supplied to you, we already have a inverting NOT gate there that you can activate using the mode switch on the board. The other thing that is very important for any kind of electronic circuit is the voltage regulator, because most of the electronics works on a specified voltage, that is a 5 volt or 3.3 volt. And this is very important because the battery that we are going to use may not be a 5 volt or 3.8 volt. It can be 6 volt, 9 volt, 12 volt, 18 volt, anything. So in order for it to protect our circuit and in order for the electronics to perform nicely, we need to regulate the voltage. So what happens is that we use a 7805 regulator, and as you can see here, whatever be the V input, your V output will always be 5 volt with a 7805. Similarly, you will get a 7806 regulator where the voltage output will be 6 volt. 7809, the voltage output will be 9 volt. 7812, the voltage output will be 12 volt. Now we are going to see the main components in our LCLFO. We are going to see the main components are which are present in the LCLFO PCB board that is supplied to you. So the main components in the LCLFO PCB board is the L293D, which is already discussed, voltage regulator, this has also been discussed, and a NOT gate transistor, this has also been covered in the previous slide. So you can see here, this is the L293D IC. These are the two inverting transistors for the NOT gate, and to activate these NOT gate, we have the mode switch over here that you can toggle on and off. So based on that, your signals coming from the sensors will get inverted or non-inverted. And then you have a voltage regulator here. So this is the IC, which is the voltage regulator 7805, and these are the various terminals for connecting the motors and the sensors. So again, one more photo of interfacing points in LCLFI board. So this is the on-off switch, and this is the inverting switch. Here you connect motor 1, here you connect motor 2, here you connect the power supply, here you connect sensor 2, here you connect sensor 1. And as I said, using this inverting switch, you can whatever signal, let's say the sensor 1 is giving a high signal. If you use the inverting switch in the on position, the high signal will get converted to low signal. Now you can use this particular slide to build your robot using the materials provided to you. So just go through this one by one step and you should be able to build your LCLFO robotic car. And this is how your final robot will look. So here the photo is being shown with the LDR sensor, but the one that you are going to build is a line follower robot. So for that, instead of this LDR sensor, you will be using the photodiode IR proximity sensor as is shown in the this sensor. You are going to use this sensor. So the working of this LCLFI board, I will explain a little bit. So we'll come back to L293D. So in a L293D, so what happens is that this is the point in 1, in 2, in 3, and in 4 where we are going to give the sensor input and your output motor is connected. So this part remains same. This part which you see here is remaining same. Only the difference is in this part. So here what we have modified in our circuit is that instead of in 1 and in 2 where we are supposed to give two different signals, so since we are not using any microcontroller here, so we are making use of only single input. The other input we have always connected to the ground. So input 2 we have always connected to ground. Similarly input 4 we have always connected to the ground. And in 1 and in 3 we are sending the signal through a sensor 1 and sensor 2. So consider sensor 1. So let's say your sensor 1 is right now a proximity IR sensor and an object is placed in front of the sensor. So what happens is that the IR reflects from the sensor and the sensor gives an output of high. So when the output is high, the motor 1 will start rotating in a clockwise direction. Now let's say you don't want this to, what you want is that when your output is low, that time let's say you want to rotate the motor. So what you will do is that you have the mode switch, you have this inverting switch here. If you press this inverting switch, what will happen now? When your output is low, here, that time the inverting switch will make your output to go high and input will be high and your motor will start rotating clockwise direction. So here you will not be able to control the direction of the motor. The motors will always go either off or go in a clockwise or anti-clockwise direction. You will not be able to make motor to go in clockwise, anti-clockwise both. You have to invert, because for that you will need input to be high and low, but here input to be always grounded. So your motor can either be stopped or it can go in a clockwise direction. And if you use the inverting switch, it will happen vice versa. So that is how your circuit is functioning. So build your robot and share your feedback on the robot, and we'll see. And I hope that this session will help you understand about robotics and like how you can build your own robot. Thank you.